Okay, so we're on page 331. We are, oh, now I've got this right. Okay, now I can see both of you too. Okay, and we're looking on page 331. We are looking at the graph of the path of the basketball. We're considering questions A and B. And who would like to read for us question A and give an explanation? Yes, Avon.
Okay, so the question is, explain why the height of the ball is a function of distance from the foul line. So distance from the foul line is on the bottom, and then height of the ball, and then height of the ball is y. And for every distance, there's only one, like, height of the ball for this stuff.
That's right, very good. So one of the cues is definitely from the graph, which is that it passes the vertical line test. And for every distance from the foul line or distance towards the hoop, there's just one height of the ball.
Also, if you think about it, realize the ball's not going to go like this and, like, come back.
Yes, no, that would be very surprising. If you were to like shoot the ball and then it came back towards you.
It bounced off the backboard.
That's true.
We're
So
talking about the national cloud.
yes, so but unimpeded, without a collision, it would be very strange for the ball to change direction. In my mind, immediately it's like a cartoon and something's making like that woo 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 sound, you know, as it's like twirling around. But yeah, that.
It's like tornado it.
Yeah, right, exactly. But for that, we would need to have, yeah, we would need to introduce something that could explain something that is not part of nature. So it would have to be like an animation or something like that. Okay. So then we move on to part B, which is related but different. Yes, Walter.
I think that's
Yeah, read the, well, it's not really a question. Read the request and then provide your explanation.
Explain why the distance from the foul line is not a function of height of the ball. Well, because for every one of the heights, say 12, there is multiple of these things, distances that is at 12 feet. So it's at 3 and at 13-ish.
Right.
13 and a half.
So in other words, it's like if we rotate the graph and we try and do the vertical line test on it, it will fail because you're exactly right. Like at a height of 12, it would have two solutions, which means it's not a function. Okay, so we've done a good job explaining it with the graph. Now, can we explain it parts A and B based on the situation? So not using the vertical line test of the graph, but then actually considering the context of shooting the basketball. Yes, Akumi.
So for B, it all depends on the shooter's height.
Yeah, so, well, yeah, no, that's a good point. Like,
Because not every basketball player is the same size. Otherwise, that would be
Yeah.
a problem.
There's like 6'3" ones, there's like 5'2" ones.
yeah, and there's ones like over, well, no, there have been two. There have been at least two. I remember in the 90s, there were two basketball players that were both shorter than I was.
Yeah.
So, yeah, so.
Not all of them like 6'3".
Yeah.
Although
Or 7.
Yeah, some of them are over 7 feet tall,
I
yeah.
think that's a bit too tall. I'm good with 6'3", 6'7"
Yeah.
now.
Oh, okay.
Right.
I thought you were first preferences.
But that's exactly right. If the distance from the foul line depended on the height of the ball, that would mean that the foul line would change based on the height of the basketball player. That would be very boring. We wait for the tape measure to cut, like every time somebody's fouled, the referee has to come out with the tape measure. Like, yeah. Yes, there would be one of the reasons like why, you know, some people prefer like a slower, more sort of like strategic game. Other people prefer like a fast, high scoring game. The people who like basketball because it's fast and high scoring, they would get so annoyed. Yeah. Why are we bringing the? Yeah.
Other people like soccer.
Yeah.
Soccer is boring.
You
Soccer.
Soccer is not boring.
Yes.
That football game right there.
That was not football. That, I mean,
That
it
was
was, but
football.
it was kind of like a lot of them don't have this option.
There's only one actually a football player on the team.
Yeah, but listen. if you
Yeah,
think
I mean,
soccer is
people-
boring,
I used to play soccer.
Soccer. I mean, it's
Clearly
that
don't
if you think soccer is boring, you're clearly in the minority because it's the most popular sport worldwide by a massive, massive
Yeah,
margin.
by a lot.
But yeah, but part of it, I think, I don't know. Like part of it, I think depends on like how familiar you are with it. Because baseball. I thought baseball was boring until I started really paying attention to like the camera angles and the commentary that were focused on the communication between the catcher and the pitcher.
It's like a lot of different.
Yes.
Like sign language, their own sign language.
Yes. And then once I started realizing how like the pitcher wasn't always just like throwing the ball as fast as they could every single time to get it like right in the middle of the strike zone, but actually there were like all these different kind of pitches, but that was just like stuff that I didn't know. But then when I became familiar with it,
It's also like you're gonna get hit by a ball that's going super fast.
yes. But like actually, so a lot of people then like when they watch soccer for the first time, they just see a bunch of people running around just like chasing a ball, and it's difficult to score.
It is.
And so
I
then
feel like you could
and
say
so
the
it's
same
so
thing
on the
about
surface it just kind of seems like, well, what are these people doing? Just kind of just like just sort of like running around on this field. But then when you realize like the different different ways that you can like set up the positions on the field and who's defending whom and like the different it ends up being a really strategic game, but only if you're familiar with it. So
But it takes forever though.
what, soccer? It's not that long.
It takes forever.
It's really
Wait,
long.
forever as in the game length or to score?
Yes.
To score and
Both.
but some people get bored with basketball because it's so easy to score. It's just like where it's just
You're gonna honestly.
so I mean
But soccer, I don't think hard to manage much like a goalie or something.
Oh, yeah.
It kind of
but then I've heard
does.
so here's another controversial point. I've heard people say that golf is a game, not a sport, because nobody's defending the hole. There's no linebacker on the green. There's not a goalie.
There's no one defending the fan hole.
So anyway, there's people.
Golf is just like for people who can't be bothered doing any other sport.
That's such
like
Golf is cool.
I don't. Well, okay. People clearly have a lot of opinions about this.
like
Let's.
you're putting a ball in your
You're
like
just standing there and hitting a
it's
ball.
you're going against yourself.
Yes.
You're going against how
It's
well
fun
you
to
put
watch.
a ball into a hole with like a whatever the thing's called.
It's
A club.
Yeah.
Yeah. No. I mean.
Prefer basketball or soccer.
Anyway, we've diverged a little bit, but yeah, it's the distance from the hoop is not going to be a function of the height of the ball. The hoop's not moving, the foul line isn't moving. Really, it's the altitude of the ball that is changing. So we can see how this is. Sometimes things seem to kind of be two-way streets. Like they could work as a function either way. But then there's some things like this that definitely are not. Okay, so let's continue on to part C. Read part C. And you can see that there are actually 6 parts of C. So take a minute to just read through the parts, answer the questions for yourself, take some little notes if you need to, or just think about it in your brain. And then we'll come back and answer them together. So,
A ball 5 feet in the air is
so it might be worthwhile if you are, I would say if you are, if you're not sure like in part 1, part I, h of 5 equals 14. If you're struggling to remember, and here we're using h instead of f, which they do sometimes, but you can think of it as f of 5 equals 14. If you're struggling to remember how that relates to the graph and what's being input and what's being output, I would go back and look at some of your work from the prior assignment, because that is, using that notation is something that we've done before. We'll start with 1 through 3, and then we will look at 4, 5, 6 separately. All right, so let's come back to number 1 then. Milo, did you have the chance to?
Yeah, I was just looking at it wrong. I
Okay.
thought X meant the Y thing,
Oh,
not the
okay.
X thing. So
Gotcha.
Just messed up.
That's okay. Yeah, no, it's easy to get those backwards.
Yeah.
Oh, I messed that up. Well,
What?
I messed up the whole thing.
So this is why we're practicing, because we got to make sure that we're keeping organized. So our x is always going to be our horizontal axis. It's going to be our input, and so our x in this case is the distance from the foul line. I'm guessing they used h of x for height in this particular case instead of f of x for function.
Wait, but h of x, because h of h equals 5, and if you go to 5, it does not equal 4.
But remember, that doesn't say h, when h equals 5, what does x equal? This says h of 5, which means what's the height that we get out if we plug 5 in? So that is a reminder on what that notation means. So if you plug in 5, if you look
Oh,
at,
yeah, I did this whole thing totally wrong.
okay, good. So this is why we're reviewing it again.
Alright.
So when we see h of 5 equals 14, it means that we're plugging in 5
Yeah.
from the horizontal axis, from the x's, and we're seeing what we get out.
Yeah.
Oh, okay. Yeah, this makes sense.
But if h of 5 equals 14, and we can see that algebraically, what does that mean if we're just explaining it in plain English? How can we restate that in plain English?
It means when,
So hx equals
That's right. Yes. So if we were to then just restate that as simply as possible, who can take a stab at restating that as simply as possible? Yes, Aben.
When the ball is 5 feet from the foul line, it's 14.
Yes, very good. When the ball is 5 feet from the foul line, it is 14 feet in the air. Very good. All right, so now we're moving on to 2. Let's see. We had a lot of Milo and Aben on that first one, so I want to hear from somebody else on part 2. Liam, why don't you go ahead and read the questions for us, and then tell us what your thoughts are on it so far.
What value of y satisfies the equation y equals h(n)? What does that fact tell you about the flight of the shot? So I thought with y. So I looked at 10 on the x, and then, or I went up and I looked like 15.
Mm-hmm.
What does that say about the flight of their shot?
I mean, I'll be honest with you. I'm not totally sure exactly what they're getting at with this question, but tell us what you think, Liam, and then we've got a couple other people who have some thoughts on it that they're willing to share too.
I'm not sure. I'm not sure.
Yeah, I'm not totally sure what they're getting at. What did you think, Akumi?
I'm probably wrong, but would y equal 28?
Well, so here the first part that Liam shared, which is that h of 10 is about 15, is correct. So the way that we get there is we find 10 on the x-axis. And then we go up to the graph and see how high that is on the y-axis. So the y-axis does not go up to 28. So explain where were you getting 28?
Okay, my bad.
No,
I'm
but
multiplying.
oh, multiplying. Okay, so when we see the parentheses, we want to multiply. But this is a reminder that when we are doing functions, if we have like here, if we have h of 10, here we are talking about, it's like we're doing the recipe. It's like h is the recipe. So we're plugging in 10 and we're getting out. In this case, what we're getting out is 15. But we're not doing, we're not multiplying. We're doing the h function. In other words, we're finding the height.
How are we getting 15?
Well, so if you look on, so the x-axis is the horizontal axis. 10 is not labeled. We have 9.
We have 12.
And we have 12, and we see that there's 3 spaces in between. So it's just like, so it's like, yeah, so like every hatch mark is 1. So we get to 10. And then now, so then it's a little bit more complicated, but if you start at 10, Jelena, and you go straight up, yeah. And so we can see, like, we're basically falling halfway between 14 and 16. Yeah. Good. Okay, so in problem 3, or in part 3 of C, we're saying what values of x satisfy the equation 10 equals h of x. So who can remind us what the difference in the process is here? Because in part 2, what is the variable? In other words, what's the value that we're looking for in part 2? Well,
Oh, part two? Oh.
in part 2, so yes, so you're correct. In part 3, we're looking for x. We don't have x, we're looking for x. In part 2, what's the part that we don't have?
Why?
Yes.
So. can I
Yes,
go through it?
yeah, go ahead, Liam.
Okay, so, since we're looking for, x, we have y is 10 already, so we go up to row 1, we have 10, which between 12 and the 8, and we go along and we see that, the answer is, let's see,
1.75.
yeah, basically, and if we keep going, I think 15 or something.
Yeah.
So, not a function, or maybe never.
Yeah. So it's not a function, but we can find the distances from the foul line where it is 10 feet high. And you're right, it's, yeah, I mean, Walter, you're saying 1.75. I mean, it might be 1.67, but it's somewhere after 1.5. Look, so then Liam, then just going a little bit farther,
I thought it was 1.8.
so it could be 1.8.
Wait.
But using taking the logical step a little bit farther. So at 15 feet, it is a 10. The graph comes to an end there.
It's 1.67.
Okay, we're getting needlessly sucked into precision as to whether it's 1.5 or 6 or 7 or 8, but it's in there. But what else? What other information can we surmise from the graph? Where the graph ends. So what can we surmise in the real world that corresponds to?
15 feet is a backboard.
Yeah, so the backboard is 15 feet away,
And it's 10 feet high.
and the hoop is 10 feet high. Yeah.
I thought it was 9 feet high.
Let's. I'm gonna Google this quickly. Okay, NBA hoop height.
I think it's 10 also. Like, if it were 9, I mean, I could dunk in a 9-foot hoop. I'm practically 7 feet.
Oh, you are?
Oh, I'm actually
No
5'6".
way.
10 feet.
Darn it.
It's 3 meters, but that approximately, but that's about 10 feet, not 9 feet, because a meter is longer than a
I
yard.
like using dull pencils. I never use sharp
That
pencils.
was dull.
Yeah, this is not dull. This is perfect.
All right, so let's keep going. Let's turn the page. Now, we are returning to some vocabulary terms that we went over last time. You may need your notes. If you need your notes, it's fine to grab them. And for this, I'm going to start writing this part up on the board. But when we're looking at 4 and 5, it's expecting us to know the definitions of 2 words, domain and range. All right, and so for this, for your notes, you may want to copy that parabola onto your notes. The one from this problem, the basketball parabola. And I'm actually, because I don't have graph paper, I'm going to mark a couple of these points on the board.
This is just a. Wait, the one under investigation 2?
No, the one that we've just been talking about. So the one related to this problem. So the basketball one. And so this is
Only certain things work on.
distance
Yeah.
from foul line. This is height of ball. So this is h of x. This is x. And this this point here, this is where the hoop is. And I'm gonna say, based on this, I'm gonna say this guy made the shot.
Probably.
Because he's 15 feet from the foul line and the hoop is at a height of 10. So
What was
this,
this? Did they tell? I don't see. It'd be a lot easier if they told us who was shooting it. That's what I really care about.
right,
And if you make a shot, of course. If you didn't, then I mean, well, what's
Yeah.
the point of even giving us the
exactly. So we're gonna assume that this shot was made, and it can just be your, you know, your favorite player from your favorite basketball team. But now we're talking about two very important words, namely, we are talking about domain and range. And I'm putting the domain with the x-axis and the range with the y-axis for a reason. Who can let us know what that reason is? Yes, Akumi.
Domain is every possible outcome from the x-axis, and range is every possible outcome from the y-axis.
Yes. So I'm gonna modify that slightly because the domain is all possible inputs, not outcomes. So the domain is all possible inputs, so all possible x's. And you are correct. The range is all possible outputs, okay, or y's. Okay, now the way that this question is worded, let's see, Jelena, will you please read for us the question number 4, or part IV?
What are the practical domain and range of the function as shown on the graph?
Yes. Why do you think they put the word practical in there?
Because there are unpractical ways to do it.
That's true. Yes. Because in this case, like, can you think of a number that, for example, would be ridiculous to plug in?
5,000?
Yes. So that's not even going to be in the stadium. So, so, you know, or how about, I don't know, distance from the like, you know, how about like, you know, I don't know, -5. So now it's like behind. I mean, I don't even know what that means. It is possible, but again, it's not. The key word here is practical. In other words,
It's more future.
what would we actually? Yeah, exactly. If it's not the Harlem Globetrotters, like, what's a shot that we're actually expecting to see during a regulation game? Yes, Jolita.
You know, I saw them and
You
one of
did?
them- yeah, at job hunt and they gave me one of the like arm wristbands.
The wrist. Oh, you have.
Yeah, my dad took me when I was little.
I'm jealous. I've never gotten to see them in person. I've only seen them.
I see them on like video.
Yeah.
And they get it from the book.
Yes, exactly. And they were on Scooby-Doo one time. Okay, so keeping in mind then that we're actually talking about the practical domain for this actual graph. Well, this is a really good question, actually. Let's say that we're talking about a foul shot. We're actually talking about the player is fouled, and now they are taking a shot from the foul line. What is the domain of that situation?
15 feet from the foul.
15 feet, that, yeah.
15 feet, that's less than 15 feet. And
Well, this is where the player can be, but wait a minute. Is this a graph of the position of the player?
The ball.
No, it's the position of the ball. Okay, so we're talking about the ball. We're talking about a foul shot. What is the practical domain? When we're looking at this function,
Well,
what are the possible inputs into this function specifically?
it can only end.
So the 15 is the only number that we can plug in.
No.
well,
If
It has to be
15,
less than 15.
it's gotta be,
15 or less. So right,
Less than
less than or equal to 15.
yeah.
Wait,
Isn't it 1 for
Yeah. So it starts here, if this is really, so it starts here where the player is standing, and it ends here where hopefully it's going into the hoop. But this practically, this is the only, if we're talking about distance from the foul line, and we're starting in the foul line and we're going to the hoop, and again, this is an adept basketball player. So they're not just like, whee! You know, they're not just like throwing it over their head or like into the stands or
Get a sock player and then kicking it.
yeah, right.
I like to do a basketball stuff. And that's just because I'm tall, I can't really jump very high. So I can just jump
Yeah. So
The 10-foot move.
Yes.
so in this case, that's it. This is the practical domain.
Why is X in the middle?
Because we're talking about the possible inputs, in other words, the possible x's. And x is going to be between 0 and 15, including 0 and 15. So that's what this less than or equal to. Having this equal sign here means that we're including 0 and we're including 15. The ball can be 0 feet from the foul line, the ball can be 15 feet from the foul line. Okay, so now we come to L'Orange. We come to L'Orange and the range. Range. Yeah, get some real twang on it. So now we're talking about the range. What is the practical range of this function?
0 to 16? Because it's like right now.
So this is a really good question. Is
0
it?
to 15.
Yeah. So how high does the ball go?
15.
Yeah. A little bit over 15. So maybe we'll say 15 and a half. So maybe this point here. Oh yeah, it's not gonna be right in the middle because this thing gets interrupted. So it's what's the
15.75.
15.75?
Yeah, that looks,
And where does that happen at 8?
15.6.
it looks like 8.
I would say
Yeah, 8. No, it's like 15 point.
No. Yeah, 8.
15.6.
15.6.
I split the difference. I put it 15.7. Okay, so there's the apex of the trajectory. But let's get, what would it mean if we included a height of 0? What would that mean about how the player was shooting the ball?
from the ground.
Yeah, they're doing grandma bowling style. So when we're looking at the graph and we're considering the situation, what is the practical range for this graph?
7.
Wait, it starts it all at 5, right?
It starts at 7.
Well,
Oh, wait, yeah, you're right.
Yeah, it starts at 7.
Depends on how tall the person is.
Yeah.
Well, in this case, the person is exactly, well, their arms are exactly 7
So
feet tall.
it would
Probably
be,
about 6 foot tall.
it would be X and Y in the middle, and then on one side 7 and one side 15.
Yeah. So this is the practical. This is the practical range. Yes, Milo.
So would it be wrong to write like 7 through 15.7, like with just a dash mark?
It would, because it's really important. So that's a really good question. I'm glad that you're asking it, Milo. But the reason why is because the range very specifically applies to the Y, and the domain very specifically applies to the X. In other words, both of these represent a lowercase r like range of numbers. Like range is a word that we use colloquially a lot, you know, from this to this. You know, the temperature today is going to range from 54 to 82 degrees or whatever it is. Range is a word that we use colloquially a lot just to indicate sort of like a spread of numbers. But when we're talking about the range of a function, we're always talking about the y's. And when we're talking about the domain of a function, we're always talking about the x's. And that as we can see, like in a graph like this, it's not a function both ways. The height is a function of the distance, but the distance is not a function of the height. And so, yeah. So distinguishing between the two ends up being pretty important. That's a really, really good question. Thank you for asking it, Milo. Okay, again, with the terminology, I'm still getting used to this book. I'm not totally sure what they mean by function rule. Would you expect to provide a good algebraic model of the relationship shown in the graph?
I don't know.
But what kind of equation produces a graph of this parabolic shape?
A squared plus b plus c.
That's right. So I think that that's what they're going for in number 5. This has to be a quadratic equation in order to produce a parabola.
You can get a mountain. Sorry.
What? What?
Mountains.
Well, that's
Sorry.
nice.
I'm so sorry.
Clear day.
What? Mountain?
That's way too far away.
You can't see them from right there?
I hit a little bit. Not a lot.
Okay. That was a tangent.
Okay.
So the final part, part 6, I don't know, if we have ax squared plus bx plus c, in other words, just representing some sort of
Dang.
generic parabola.
That was our theoretical.
Yeah, so now for part 6, part 5 and 6. Now we're talking about, okay, what's the theoretical domain and range of a parabolic function?
There would still be a range limit for like the greater than, but there wouldn't be one for less than.
That's right. So we could see for the range there would have to be a maximum.
Yeah.
So the y, so for the range, the y is gonna have to be less than or equal to some maximum value. It has to be.
Wait,
Yes, Milo.
is this for question 5 and question 6?
Yes, so 5, we said, okay,
Okay,
the wording of question 5 is a little bit confusing,
Alright.
but in order to get a parabolic graph, we need to have a quadratic equation. But then for part 6, okay, then what's the theoretical domain and range? Yes, for the range, if the parabola looks like this, there's going to be a maximum that it won't go beyond. How about the theoretical domain? I'm going to you on this one, Walter. Yeah.
It would be, well, right? There's no limit.
There are no limits, that's right, because this is just going to keep going this way, and so we can't find an x that we can't plug in. Does anybody remember what the notation is if there are no limitations?
Infinity.
No.
That's true. We can we can go from negative infinity is less than x is less than positive infinity. So we can write it that way, but we have a shorthand. We have a shorter notation that we talked about in the last class. If there's no limitations, how can we indicate that? Consult your notes.
All real numbers.
All real numbers?
Are we down?
That's right. So we can do a capital R like this for all real numbers. Yes. So theoretically, a parabola, a parabola like this, it will have a maximum. In other words, the range will be limited, and it's going to be limited at, in this case, 15.7.
So all real numbers thing is like, yeah, I can do all real numbers. You better not like put in like a random little like pony in there. And
Yeah.
that's a real number.
Yeah, don't put, we'll talk about imaginary numbers later in the year.
Yeah.
But we can plug in all real numbers, so there is no limitation on the domain. So we have a limitation on the range, not on the domain.
Imaginary numbers is square root of 1 or something, or the square root of negative 1.
Yes,
Something like that.
that is the imaginary number. Yes, Jelena.
So the two lines, like 2, right?
Yes.
That means all real numbers?
Yes. So it looks like a 2, but really it's a bold R. So
But
sorry,
could I put
my
like a-
handwriting is not as good
So the
as
lines
it
are
should
kind
be.
of,
It's an R with a dash.
It's an R with like a double vertical stripe. So another way to do it is, like if you write an R, you can just put another vertical stripe on it, and that means all real numbers. Yep. Good. Okay, so now what I'd like you to do, and let me double check where we are on time. Okay, so this is what I want you to do for the next class. I want you to read on page 332, investigation 2, starting out designing parabolas. So you read that page on page 332, and then you do your best on A, B, C, and D for problem number 1. And then that's what we're going to talk about when we come back to class next. But I do also want you to post the work that you've done on it on Google Classroom.
And the assignment?
The assignment has not been posted yet, but I'm going to do that right now. Okay, so we've got like 5 minutes right now. So my suggestion is, while this stuff is still fresh in your brain, would be to take a look and get going on the reading on page 332.